Hello children, myself Ashrit sir. In last class we discussed about your chapter atomic structure and chemical bonding. Up to page number 47 and atomic number we have already discussed in our last class. Today we will discuss mass number which is present in your chapter page number 47. What is that? As you know, an atom consists of protons, electrons and neutrons. The mass of an electron is negligible as we discussed. Therefore, the total mass of the atom is confined in the nucleus due to the presence of proton and neutron only. So, the sum total of neutrons and protons inside the nucleus of an atom is called mass number. The mass number and atomic number of first 20 elements are given in your book, page number 47. In the next slide, I will show you. The mass number is represented by capital A. The atomic number and mass number are written as subscript and superscripts alongside the symbol of element respectively. As an example, just see X is the element, A is the superscript which is written as the mass number, and Z is the subscript as the atomic number. So when the element X, where A and Z is mentioned, you can calculate Z is the atomic number which is equal to the number of protons as well as number of electrons. A is neutrons plus protons. So ultimately you can calculate neutrons is equal to atomic mass number minus atomic number. If the atomic number and atomic mass number of an element are known, then it is possible to calculate the number of subatomic particles of that element, like electrons, protons as well as neutrons. Okay. So as I was discussing about the table, the mass numbers of certain elements are given in the table. So you have to remember certain mass numbers of serially 1, 2, 3, 4 it is given, that is the atomic number you can calculate, whose mass number are given by the side. Up to 20 elements it is given in the table. So you have to remember the elements atomic number as well as the mass number. Okay. Now we'll discuss about the arrangement of electrons in different cells. It is given by Bohr-Bury scheme. As you know, electrons are arranged in a specific cells or energy level. This arrangement of electrons in various cells of an atom of the element is called electronic configuration. What is electronic configuration? The arrangement of electrons in various cells or orbits of an atom of the element. Clear? So the distribution of electrons in different energy cells of an atom is governed by Bohr-Bury scheme. What is this? According to this scheme, the maximum number of electrons which can be accommodated in an energy cell or orbit is given by 2n square, where n is the number of cell or orbit. So the electron orbits and maximum number of electrons that can be accommodated in them are just given in the table. You can see the first cell, that is K cell, where cell number is 1. So if you calculate the number of electron in K cell can be accommodated is 2n square. Instead of n, if you put 1 square, then it is coming 2 electrons. Similarly, L cell, which is the second orbit, so n is 2, which accommodates 8 electrons. M cell 18 electrons. N cell 32 electrons. So the outermost cell of an atom cannot accommodate more than 8 atoms. Even it has the capacity 8 electrons, that is electrons. Even it has the capacity to accommodate more electrons. If however outermost cell is K shell or first cell, then it can hold the maximum of 2 electrons only. Then electrons in an atom do not occupy a new cell or orbit unless the inner shell are filled. So first go on filling the orbits one by one, K, then L, then M, then N. So certain diagrammatic expressions are given in our next slide. So these are the electronic configurations we can discuss. Suppose hydrogen having atomic number 1 means number of electron is 1. So electronic configuration in 1 is present in first cell, K cell. So 1 will be there. Similarly, if you go for boron, which is having atomic number 5, means it contains 5 electrons. So how it is giving the electronic configuration? The K cell which has accommodated 2 electrons, then how much left? How many left? 3 electrons. So 2, 3 you can write. Similarly, you will go on writing like this. Suppose chlorine atom contains 17 electrons. Okay, so the electronic configuration will be 2, 8, 10. 3 cells will be there. First cell accommodates 2 electrons, second cell 8 electrons, and the third cell rest of the electrons. So like this, calcium last one having the atomic number 20, which has 20 electrons. The electronic configuration will be 2, 8, 8, 10, 2. So it will be divided, the last orbit should be completed, because you cannot write 18 because 20 means first cell it contains 2, the second cell 8, it coming total 10, then how many left? Another 10. So third cell accommodates 18 electrons, but you cannot write 10 directly. So to complete the satisfy the third orbit, you write 8, then rest of the electrons you will write in the outermost shell or N cell, to having 2 electrons accommodated. Clear? In this way you have to remember the electronic configurations. Now we will discuss what is valence cell. Valence electrons. The electrons which are present in the outermost orbit are called valence electrons. In chemical reaction, only the electrons present in the outermost cell of an atom take part. The valency of an atom is decided by these electrons. Therefore, the electrons present in the outermost cell of an atom are called valence electrons. So, normally, as we discussed earlier also, what is the deficiency of valency? The number of the capacity of combining electrons. Okay. So the number of electrons that take part in the chemical reaction, that is the valency of the atom. Okay. Similarly, the electrons which are present in the outermost cell, they are called valence electrons. For example, the electronic configuration of sodium, you can go back and you can see the electronic configuration is 2, 8 and 1, because the atomic number is 11. So the configuration we are feeling like this: 2, 8, then rest is 1. So in this way you can show it diagrammatically, the electronic configuration of sodium atom. Okay, see the figure. At the center it is written 11p because the atomic number is 11, which is number of electrons and number of protons, both are 11 each. So in the center it is written 11p, and the first orbit which accommodates 2 electrons, and the second orbit which accommodates 8 electrons, and the last with the rest of the electron, only 1 electron left, which is in the last orbit. Clear? This is all about your valence electrons. Like this we are having in your chapter, page number, I think it is 47 or 48. So many diagrams are given of various elements. Starting from 1 we are ending at 20, calcium. How the electronic configurations are represented diagrammatically. So you have to remember the electronic configuration and the diagrams of each atoms of the element from 1 to 20 atomic number. Okay, this is all about our discussions about your chapter atomic structure. Okay, next class we will meet. Any doubt you are free to ask me. Thank you, children.